Network in graph theory. Today I would like to discuss with you network in graph theory. Subgraph. What it means by subgraph. Subgraph. Graph X, graph Y, and graph Z. So you're given E3. So graph Y is the subgraph for the graph X because E3 is actually from the graph X. It's exactly the same. So that means you can cut and paste. If you can cut and paste it, you can cut the graph Y and paste here. That means it is subgraph. The same thing apply to E1. It's exactly 2 units, right? So the graph Z is not the subgraph because the length here is not 2 units. So the length must be equal. Whereas if you see the length for E3, this one, and also the direction is heading up 2 units, 2 units. So this is exactly the same length. So a graph Y is a subgraph of graph X. So we have revised the subgraph. Okay, now let's revise on simple graph. What it means by simple graph. Simple graph means if you have the graph looks like this, whereby you got point A, vertices there, vertices A, B, C. So let's have a look. For simple graph, we can represent in terms of the E equal to a set consists of A, B, comma B, make sure you write comma, edges, and then comma B, comma C, and finally we have A, C, A, comma C. So number of edges is 3. What about total or sum? This means total or summation. It looks like S, right? Summation of the degree of vertices is 2 times number of edges. So you can say 2 times 3. Just times 3 with the 2. Okay, so number of the degree is 6. So this is definition. Definition for graph is a series of dots that are either line or not line by lines. So graph can be dot, or it can be a line, or can be not line by lines. Graph theory is study of graphs. Network is a graph where the edge and the vertex have attributes. So vertex we use dot. Vertex we use dot. Edge we use line. Edge we use line. Loop, what it means by loop is an edge in the form of arc. Edge in the form of arc that starts and ends at the same vertex. That's definition for loops. degree. What it means by degree? Degree is number of edges connected to a vertex. Number of edges connected to vertex. That's the definition for degree. Example, we have one vertex A. We have how many edges? 3. 3 edges connect to vertex A. So the degree of vertex A is 3. Multiple edge means more than one vertex connecting to 2 edges. Example, we have vertex here. We have more than one edges. So multiple edge. Directed graph is a graph that have direction assigned to the edges. Example, from A to B. Okay, from A to B, we can draw the arrow. Right, let's draw again. So I'm going to draw from A to B. Okay, I can draw the arrow. So this is become a directed graph. A weighted graph is a graph that have weight, means value can be in terms of distance. It can be in terms of the cost, can be in terms of the times, or whatever value assigned to the edge. So subgraph is actually a part of graph. Sub means part of. Okay, sub means part of the graph, where the position of vertex and edge does not change. Condition is vertex and edge does not change. Tree. What is tree? Tree is a cyclic graph. Tree is a cyclic graph. So for this topic, the most important formula or principle is you must know that important formula and principle is you must know that sum of the degree or total degree is 2 times number of edges. Okay, if sum of the degree not even, then graph cannot be drawn. Graph cannot be drawn if it is not even. That means odd. If it is odd, you cannot draw the graph because of the 2 here. Okay, sum of degree must be 2 times of the edges. One loop, the degree 2, clockwise 1, anti-clockwise consider 1. So for a loop, it consists of 2 degrees. This is important, please highlight. Okay, let's say you have a loop here. So clockwise consider 1 edge and anti-clockwise the other edge. So the degree for a loop is 2. Simple graph is a graph without multiple edge and loops. There's a definition for simple graph. Graph without multiple edge or loops. D here means that number of edges that points away. There's a small letter of the in. D in. It means that point away from the vertex. In directed graph, the order of vertices is when writing the edges is always written according to the direction. Must follow the direction. If A to B, we have to write AB. We cannot write BA. It's not the same. Each graph is a subgraph of itself. Okay. Okay, every graph is a subgraph for itself. In a tree, all vertices is connected and each pair is connected with one edge. For a tree, make sure it's only one edge. All the vertices is connected to each pair is connected with one edge. That means a tree cannot have loops and multiple edges. So for a tree, number of the edges is equal to number of vertices minus 1. Again, I'll highlight to you, this is important. For a tree, number of the edges is number of vertices minus 1. So we have quite many important formula like this one. You have to memorize it. Number of total degree is 2 times number of edges. Right. So how to draw a directed graph? How to draw a directed graph given the question provided the number of degrees. Let's say they give you number of degrees and vertices like this one. First of all, you have to read the question. There is a loops at vertex O. Here, vertex Q. Okay, there is a loops. As you can see here, D in is 3, D out is 2. So D in, D out. We have D in, D out. So we look at the question. We know that the RS is a multiple edges. RS is a multiple edges. So we read the question. After that, we have to calculate number of edges from sum of the degree of vertices equal to 2 times number of edges. We can find how many edges by taking total degree divided by 2, right? So if you sum up here, we have 2, we have 5, we have 3, we have 4. So total we have 14. We have 14 sum of the degree. So we will divide by 2 to get 7 edges. So we'll draw 7 lines, right? So, okay, sketch the vertices and given degrees. So we will go to the each of the vertex P. We only got 1. For the in, we have 1. For the out, we have 1. So in 1, 1, out 1. Follow the arrow. If you have the directed one, we have in and out. For Q, in is 3, out is 2. For Q, we have, let's study the Q. We have in 3, out 2. So that is how we have to draw the in 3 and then out 2. Out 2, it means that for loops, okay, we have in 3, 1, 2, right, and then for this one, 3, 1, 2, 3, 1, 2, 3. And then we can say that for out we have 1 here, we have 1 there. So it's D in. Okay, D in is this one is clockwise. The red one is considered in. This is called out for a loops, right? Okay, for the loops we have in 3, we have in 3, we have out 2. So how to see in 3, out 2, I explain again. So this, the red one, again I show, this is in, go into the queue, this is in, and this one is in. Okay, in. For out, I'm going to show you out is this one, and then this is out. So this is called in 3, out 2. Let's see for R. For R, we have 0 in and out 3. For R, we have we have 1 out, 2 out, 1 in. Okay, for R, we have 0 in and out we have 3. So this one should be out. This arrow was wrong. Okay, so let's do correction here. Out 3, no in. Alright, please take note. Then for R, in 0, out 3 setter. For S, we have in 3, out 1. Okay, in 3, out 1. So let's study the S. We have in 3, 1. For this one, we have 1, 2, 3. So this one should be out for S. For S, we have 3 in and then 1 out. So this one should be like this. Okay, we have 3 in. This is considered in, and this one will be out. 3 in and then 1 out. Alright. So that's how you draw the directed graph. So you have to study the number of the degree, then divide by 2 to get number of edges, and after that you have to study in and out, draw the arrow for every vertex, right? So then for double check, total edges should be 7. Okay, for Q, we have into 1 out, right? For Q, we have in. For Q, we have, so we haven't complete the Q, so we have to make sure we have here there's a loop here, right? So we have in 3, out 2. Yeah, this is in, and then out you can use this one is out, and then this is out, right? So in 3, out 2. Alright, so that is the way to form or to draw the directed graph. So that's all my sharing about network and graph theory. Till then, bye bye and have a nice day.